We're getting ready to finish up this session, and I wanted to go into another video for question number 5. It's going to take a little bit of explanation, and I wanted to kind of make a break between there. Okay, so I've got several fractions here, and what I want us to do before we start trying to get into the details of comparison is I want us to kind of think of a number line like this, starting with 0, put a half in the middle, and then going up to 1. And let's try to just do some basic sorting of our fractions, okay, before we get into the specifics. So I look at 10/11ths, and I know that is more than a half. I look at 216 over 423. So half of 4 is 2, half of 2 is 1. This is pretty close to a half. 1/3, that's going to be less than a half. So we've moved up to here. 14/16, that's going to live up here somewhere. 3/10, that's going to live down here somewhere. And 10/13 is going to be more than a half. Okay, so now let's think about sorting out the lower half and the upper half of fractions like these. Okay, so we've got a third and we've got 3/10, and we're trying to think about comparing those. Now, we can't really use the half comparison here because that's, they're both less than half. They didn't help us. So let's think about the size of the pieces, okay? Here I have 1/3. I have one piece that's 1/3 each. Here I have 3 pieces that are 10s each. So when we're trying to compare fractions, we either have to compare the size of the pieces or the number of the pieces. Something about those have to be the same. Here we don't have the same size. One is a 10th and the other is a third. We also don't have the same number. We have 3 of these and 1 of those. And this is kind of a little bit of a foreshadowing to our next lesson as well. Is there any way we could write the fraction 1/3 with a numerator of 3, of having 3 parts? Okay, we know that we can indeed do that. We can express 1/3 as 3/9. Okay, that is another way of writing 1/3. If we took our thirds and we split them into thirds, we would have 1/3 of that would be shaded in 3/9 particularly. So now let's try to compare these. Okay, 3 pieces that are 1/10 each, or 3 pieces that are 1/9 each. Okay, how would they compare in value? Obviously, then these are going to be bigger pieces because there's fewer. These are going to be smaller pieces because they're larger. So if I have 3 small and 3 big, then obviously, okay, my smaller 3 will be worth less, and my larger 3 will be worth more. So far, we have this amount sorted, okay? We figured out the 2 less than a half. We know we're right at a half. So now we just got to think about these ones that exceed a half, okay? So first thing I'm going to do is I'm going to think about 10/11ths and 10/13ths because they have the same number. So it might be easy to compare them. Okay, so I have 10/11ths, I have 10/13ths. These are obviously going to be smaller pieces because there are more of them, bigger pieces because there are fewer of them. So if I'm just comparing these two, then I'm looking at a 10/13ths and a 10/11ths. Okay, now we have to kind of figure out where this fraction fits in. So let's go to 10/11ths to compare it first. Now, we run into a similar problem here as we did over there, okay? We don't have the same count. We also don't have the same size. But we can notice that this fraction, this 10/11ths, is 1 away from a whole. Is there any way we could express 14/16 so it is 1 away from a whole? Sure, we can simplify it as 7/8, right? It's equal, equivalent fractions here. We just took every 2 pieces of these and combined them as a single group. We would go from having 14 to 7 and 16 to 8. All right, so now let's think about how 7/8 compares to 10/11. This is a big piece, a small piece. This is a small amount away from the whole. This is a larger amount away from the whole. So this guy is further back from 1 than 10/11. So we know it's going to be smaller than 10/11. What we also need to know is it going to be smaller than 10/13. Okay, so let's think about that. Let's go back to 7/8 and let's see how it might compare to 10/13. We run into another problem. We don't have the same count, and also we have different size pieces. But let's look at this one. It's 3 parts away from a whole. Is there any way we could express this to where it's 3 parts away from the whole? Okay, here it was 1 part away from a whole. When it was in this form, when we doubled both, it was in 2 parts away. So what if we were to triple the numerator and the denominator? Okay, we would have 21/24, right? That's an equivalent fraction to 14/16. So let's compare it here. These are going to be, okay, 13ths, 10/13ths, 3 pieces, okay, missing there. And we have 3 pieces missing here. So when we are trying to make this comparison and decide where that's going to fit, okay, if we're looking at that breakdown, we want to start thinking about how those two will compare to each other. So here I'm missing 3 big pieces, and here I'm missing 3 smaller pieces, okay? So how could we express that, and what would it tell us about the order of that fraction, okay? Obviously, since these are bigger pieces than these, since you are missing the same amount, this would be further back away from 1 because those pieces are larger that it's missing. So that means that this 7/8 or 14/16 or however we want to express it is going to fit right in here. It's going to be in the middle. It's bigger than this one, but smaller than this one. So we've got 10/13, 14/16, okay? And we also then have our 10/11. Now, if you wanted to, you could always use calculator to check your work, but you just want to be able to back it up with the reasoning that you have, okay? So what is a fraction anyway? How is a fraction different from a rational number? Look this up on mathwords.com, okay? So if we go to mathwords.com, see if I have that here. First of all, let's go and see what it says about rational numbers, okay? If we head over here to, where's the rational equation, rational numbers, there we go. It tells us all positive and negative fractions, including integers, and so-called improper fractions, okay, are all rational numbers of a set of real numbers. So fractions are rational numbers, okay? They don't differ from a rational number. A fraction is a comparison of 2 parts. If we go back to mathwords.com and we actually see what the technical definition of fraction that they give is, we can click a ratio of numbers or variables. Okay, so for us, it's going to be numbers. Ratio compared by division. Particularly a fraction is a part to whole ratio. Okay, we have 5 parts out of the whole of 8. So it's not different. It's a ratio comparison of 2 parts. Okay, or I'm sorry, comparison of 2 numbers. Top part is the parts, bottom part is the whole. Can any number be used in the numerator and denominator of a fraction? No. The exception to that is 0. We can't have 0 in the denominator. A lot of people explain that by, if we think about a fraction as division problem, we can't divide by 0, which that's true. But it's also contrary to what we've learned to think about fractions in terms of parts and wholes. If we thought about a fraction with 0 in the denominator, it would be like saying I have 2 parts out of the 0 parts it takes to make a whole. And that just doesn't make sense. Okay, it wouldn't exist that way. True or false? If a number is not a whole number, then it is a rational number. Okay, this is false. And the reason it is false is that there are plenty non-whole numbers that are not rational. For example, okay, think about pi or e. These would be good examples, okay? Pi is a non-terminating, non-repeating decimal, okay? It doesn't fit into the whole number category, but it also does not fit into the rational number category as well. Any value that doesn't terminate or doesn't repeat, okay, is going to mess this up. Okay, it's going to make this a false statement. So Sarah and Jake both found a candy bar in their packed lunch from their mom at lunchtime today. Both children decided to eat half now and save the other half for the bus ride home. Once each child ate half, they discovered that Sarah got a larger amount of candy bar than Jake did. Since both ate half, how is this possible? Okay, this has to be because Sarah's candy has to be larger. We don't know that one of them didn't have a fun size and one of them maybe didn't have a king size. For example, if Sarah had a king size Kit Kat and she ate half of it, we're looking at a considerable amount of candy. Whereas if Jake did not have a king size, just had a regular one and ate half of it, we don't have the same amount of candy. Again, we're accurately showing a half and a half. They're just not equal because they don't use the same whole or don't compare to the same whole. Okay, so hopefully after working through the session, you get a little more experience with that. I don't want you to freak out too bad right now if question number 5 was a little bit of a challenge for you. There's a lot going on in there. And we also had to often think in terms of equivalent fractions, which is what we're working on next time. So if that's something that you struggled with, that's okay. That will be something that we continue to come back to. But hopefully after seeing it worked out, that's something that you're able to make sense of.